So what do I mean when I say a system of linear equations? Well, we know what an equation looks like, and specifically a linear equation is an equation in which all of our variables have only the power of 1. So an example of a linear equation might be x plus 2y equals to 7. So the power of x and y here are both equal to 1. And what we're going to do is we're going to take a look at a system of linear equations. So that means 2 of these types of equations or more. So I could add another one in here, maybe 3x minus y equals to 15. I'm just picking my numbers here at random, just making sure that the powers of x and y are equal to 1. So here is one such system of linear equations, and in this lesson we want to develop ways to solve this kind of system. And when we say solve, we mean we want to satisfy both of these equations at the same time with particular values of x and y. As we're working through the next couple examples and solving our linear systems, I just want to note before we do that the 3 types of solutions we might get when we're solving. The first type of solution is called a unique solution, and this occurs when our final answer, we only have one value for both of the variables x and y. The second type of solution we might obtain is called an infinite solution, and this occurs when we have many different values that are going to satisfy our system for both of the variables x or y, or for one of them. The last type of solution we might obtain is called no solution, and this means that we're unable to find values of x and y that are going to satisfy all of the equations in our system at the same time. The first method we're going to look at is called the substitution method. Now in this method we're going to break it down into 3 simple steps. First, we're going to take one of our variables and isolate for that one variable. So we take one of our equations, solve for either x or y, whichever one happens to be easier. Once we've isolated, we're going to substitute that into our second equation. This should allow us to solve for one of our variables. After we've solved for one of our variables, step 3 is to backwards substitute. So we take the value that we've solved for, and we work backwards to get the second value that we need for our linear system. Let's solve the following linear system. Our first equation is 2x minus y equals to 5, and our second equation is x plus 4y equals to 7. To make our equations a little bit easier to refer to, I'm going to call them 1 and 2. So I've done that here in blue. What you want to do first is you want to solve for one of the variables. So you want to take one of your equations and isolate a variable either on the right-hand side or left-hand side. I'm looking at equation 2, and if I move this positive 4y over to the right, then I can isolate for the variable x. So let's do that first. Now a good habit to get into is to actually write down what you're trying to do. So here, I'm hoping to isolate the variable x in equation number 2. So I take my x plus 4y equals to 7, and I copy that down, and I'm going to subtract 4y from both sides to get x is equal to 7 minus 4y. So here, we've isolated x. X is by itself on the left-hand side of our equal sign. Now that we've isolated for x, we can move on to the second part of our substitution method, and that's to do the actual substitution. So again, I'm going to state what I want to do. I'm going to sub x equals 7 minus 4y into equation number 1. Okay, so here I've copied down equation number 1, 2x minus y equals 5. Everywhere we see x, we're going to substitute 7 minus 4y. And we can use the distributive property to get 2 times 7, which is 14, minus 2 times 4y, which is 8y. I'm going to subtract 14 from both sides. And we have negative 8y minus 1 more is negative 9y. And 5 minus 14 is negative 9. Dividing both sides by negative 9, we get y is equal to the value of 1. Now that we do have the value of y, we can move on to step 3, and that's the backward substitution method. And in this final step, we're going to take the value of y that we obtained and substitute it into this equation that we have for x, because we'd like to know the value of x as well. So, making that substitution, we get 7 minus 4 times 1, or x is equal to 7 minus 4. This tells us the value of x must be equal to positive 3. So in this particular question, we end up with a unique solution. X is equal to 3, and y is equal to 1. Now that we've seen the substitution method for solving linear equations, let's take a look at an alternate method that you can use to solve linear equations called the elimination method. To use this method, we're going to again follow 3 steps. The first step, instead of solving for one of our variables, we're going to adjust the coefficients of one of the variables. So this means that we want both of our x's or both of our y's to have the same coefficient. Now the reason we do this is because of step 2, where we're going to add or subtract our 2 equations from each other, or to each other. In this second step is when we're going to be able to solve for one of our variables. After we have the value for one of our variables, we're going to move on to the third step of the elimination method, and that is to use backward substitution to get at the value of our other variable. Let's use the elimination method on the following linear system. We have 2x plus y equals to 1, and 3x plus 4y is equal to 14. Now, in step 1 of the elimination method, what we want to do is we want to adjust our coefficients so that one of our variables has a similar coefficient in both of our equations. So notice here that we have a single y and a positive 4y. So what we could do is we could take this entire equation and multiply everything by 4, and then we have a similar coefficient for both of our y's. So I'm going to go ahead and do that. I'm going to take equation 1 and I'm going to multiply by the number 4. Now what happens when we do this is we get 2x times 4, that's 8x. We get 1y times 4, that's 4y. And we get 1 times 4 for the number 4. We haven't done anything to our second equation, so I'm just going to rewrite that down. And this is the first step of the elimination method. You'll notice now that we have 4y and 4y, so we've adjusted our coefficients. Our next step in the elimination method is to either add or subtract our 2 equations. Now looking at our coefficients, if we take 4y minus 4y, we're going to get 0y. So let's go ahead and do that. We indicate that by placing a line down here, and I'm going to put a minus sign just circled to remind us that we're going to be subtracting. So let's work on our x's. We have 8x minus 3x. That's going to give us 5x's. And then we have 4y minus 4y, which is 0. Bring down our equal sign. And then finally we have 4 minus 14. That gives us negative 10. Now here's the big idea for the elimination method. After you do this addition or subtraction step, you should get an equation in which you can solve for one of the variables. In our case, now we have an equation in which we can solve for x. So let's go ahead and do that. If we divide both sides by the value of 5, we get x is equal to negative 2. And our final step of the elimination method is to do the back substitute portion. Now that we know that x is equal to negative 2, we're going to substitute x equals to negative 2 back into one of our original equations. I'm going to choose equation 1 just because the coefficients happen to be smaller than the coefficients of equation 2. So let's go ahead, where we see x, we're going to sub in negative 2. And we're going to try to solve for the variable y. So here, 2 times negative 2 is negative 4. And we will add 4 to both sides. And that's going to give us y is equal to 5. And that's going to finish off this example. We have the unique solution, x equals negative 2, y equals 5. right, my little epsilons, stay positive.